Alright. So, this is going to be the GPU June 2, give me a sec, I gotta mute myself. Alright, this is going to be the GPU June 2 stream. Plans for today are we are going to look at these three, well, there's 4 cards. You have the 7970 SOC, the GTX 480 Lightning, the GTX 460 WHDI edition, and then on the bench currently is a GT610 Fish. I'm going to go from rarest to least rare, and we are going to be tearing these down, taking a look, talking about some of the specs of these, and then going to transition to a demonstration version where I'm going to put these on my test bench and run some benchmarks. So we are going to set the GTX 480 Lightning and the 460 WHDI aside, and we are going to start with this, the 7970 SOC. So these cards are really rare. There were only 200 of these made. Only one was officially sent to the United States, and all the others were sold exclusively in the Asian and European market. And let's see. So this is a true 8-phase GPU. It has the standard specs for a HD7970, so it has 3 gigs of RAM, and this one came with a stock clock of 1080 megahertz. So there wasn't a gigahertz edition of this card, but it did ship with a gigahertz stock clock. Give me one sec. Need to grab my other screwdriver, which I did not grab before starting this. Alright. Here we are. And so part of the teardowns is I will be taking these apart, talking about the VRMs, what they're capable of, what made these cards so special, and then reassembling them. Now, the cool part about the HD7970 SOC is that it and the GTX 680 SOC both had this massive 3-slot cooler on them. And let's see here. Oop, I forgot this one does have 2 extra screws. And unlike a conventional cooler that just has the fans on the front that blow across the heatsink and then expel the air into your case, this one uses 5 server 40mm fans to pull the air through the heatsink long ways, so you have more fin contact, and pull the air out. And if you're on a test bench, this just pushes the air right out, or if it's on a side configuration, it'll blow the air out this way. So once you get that off, we are greeted by the PCB. The serial number on this one is number 36, and is shown right, or 34, my bad. It's hard to see, but there we go. So we'll start with the front and then work our way around back. So, and I got a little rod to help point out things. So, this is one of the few HD7970s that comes with a true 8-phase. This is the controller for it. It's a chill, if I remember correctly, yes, it's a chill 8228, and then we have a chill 8225 right here. So this is an 8-phase V-core controller, and then you have a 5-phase controller here, which controls the memory VRM. This one is in a 2+1+1+1 configuration. So you have 2 phases for memory, 1 phase for display output or your 0.95 volt rail. Then you have 2 displays, which these are driver rails for the I want to say it's the SOC voltage. There's 2 extra drivers, I forget what these ones are for, but you have 1 phase here, 2 phases here, and 2 here that make up the 5 phase on the 8225. And the 8228 powers these 8 IR 3550s, which are 60 amp power stages. They can do up to 90 amps peak current, but continuous draw they can do 60 amps. So this is capable of 480 amps, which is more than enough than you can ever pull on a 7970 without blowing it up, even on liquid nitrogen. Speaking of which, I am not a YouTube creator or Twitch creator. I'm an extreme overclocker and a GPU collector is my background, so I don't typically do this sort of thing. But I saw that they were hosting GPU June 2 and were looking for some unique cards out there, and I decided I would show off a very small portion of my collection. I have more than 70 cards at the moment, but most of them aren't really worth noting. But some of these more unique and rare ones I thought would be cool to talk about. Let's see. So we can go along the back, and yeah, I could go ahead and take off this back plate real quick. But while I am taking off the heatsink for the back plate, we can show off the vapor chamber on this thing. This is all one massive vapor chamber to cool the memory and the core at the same time, and it's connected to 5 heat pipes that go around in, like, it's 5 on this side, 4 on this side. If I remember correctly, only this one doesn't loop around, but these 4 are actually just looped all the way around continuously. And let's see. When it came to the actual, like, longevity of these cards in the extreme overclocking scene, these actually, despite being one of the best PCB designs for the 7970, never actually was a chart topper in the extreme overclocking scene. That record would actually go to the 7970 Lightning. It could be simply due to the fact that a lot of people didn't get these. They were hand seeded out to a small handful of extreme overclockers, but for the most part, these were exclusively sold in China. Unlike the 7970 Lightning, which a lot of people were able to buy. And so this kind of made it where it's a sad case of it existed, but never got the notoriety it deserved. So here on the back, we have the core. This needs to focus. And give me a sec. I can fix this. Alright, so here on the back we have the PCB, and we have these 5 Pro Analyzers. These are like really big, think of it as giant capacitors, but instead of just being a capacitor like a ceramic like you have a lot of behind the core, or a can type electrolytic, where these have a lot of capacitance but they're really slow, and then these have very little capacitance but they are able to respond to fluctuations in power very quickly. These have a lot of capacitance and are able to respond across the entire frequency range quite well. The one downside to the Pro Analyzers, though, is the fact that they like to die. Their shelf life, or their lifespan, is rated at only 1,000 hours, whereas any other type of capacitor, typically the minimum that you will see is 10,000 hours of runtime. And these things despise heat. They were originally designed to be put behind the core directly to take care of all the capacitance that the core would ever need, but none of the GPU manufacturers actually implemented these designs behind the core. And unlike where the GPU manufacturer can play around with all of this however they please, the core on these are always strictly locked down. You're not allowed to mess with this part within like these 4 holes. This is always set by the either AMD or NVIDIA, and that is law. So what you're left with is the GPU manufacturers placing these wherever they wanted to, and so you always get a line of these. These were really popular in 2012 to 2015-ish for extreme overclocking cards, but then they stopped producing these entirely. Like, they don't make these anymore, and so of course they don't use them anymore despite how good they were. And the biggest reason was that super short life that they had. And also, these had a tendency, when they did fail, they would fail to short, and so like after the 1,000 hours you had a risk of these just shorting your VRM and blowing up the card. Older motherboards that use these a lot, like the EVGA X58 Classified 3, a lot of those died because they would have like one of these right by the CPU socket to do the exact same thing as it's doing here, and they would fail to short and blow up the motherboard. Completely unfixable once that happens. But typically, like in the case of these didn't fail to short, they just don't carry the same capacitance that they used to. In fact, they're almost useless now, but they're not failed to short, at least. So this is the first card. I'm going to reassemble this real quick, set it aside, I'll talk about the next one, and then once I'm done talking of them all, then I'll do the practical demonstration. So start with this back plate. Now the GTX, the next card I'm going to be doing, the GTX 460, it's going to be unique in that this box is part of the graphics card that is just sitting off to the side. So, and another funny story, most of these cards I actually found in Australia, and they're always destroyed. Like, I had to do a lot of restoration work on these cards. For some reason, the Australians love leaving their graphics cards by the ocean, and salt water is not a friend of metal. So get these last 3 or so screws in. And feel free to feel free to send chat messages. I'm always able to see it and read them if you have any questions. The 680 SOC, funny enough, it uses the exact same cooler as this, except if you see this square right here, my 680 SOC is partially disassembled at the moment, but they use the exact same cooler, except this little shim right here is not there, and the reason being is because these 7970 cores, this metal shim that goes around the core typically sits higher than the silicon itself, so you needed this metal shim to sit into the actual where this shim is to make proper contact with the die. Also, you can always tell a 680 SOC versus a 7970 SOC by this cooler. And that's a lot of paste. Give me one sec. So, this is the 680 SOC and the 7970 SOC. As you can see, there are slight differences, but not that major. The biggest one is currently I have a bunch of replacement fans, and like I said, I've been repairing these. These are all brand new. The 680 has the shroud above the fans, whereas the 7970 does not. And you can't see it right now. The 680 uses a 3-slot design on their cards, whereas the 7970 only uses a 2-slot design right here. So, yeah, fun little note. Also, the 680 only has 4 pro analyzers versus the 5 that the 7970 has. You can get 680 SOC replacement fans for about $12 a piece. That's what I got mine for. I was able to haggle. If you were to just look on eBay, they're about $15, but if you bulk order like 6 of them, you can typically ask for like $12 a piece. Or I think I ordered 20 of them, so I got them for $10 a piece. So yeah, when I go to run this, these are actually really quiet now that they're brand new, and getting the stickers off of the old ones and onto the new ones was a pain. But it can be done with a little bit of isopropyl alcohol and some patience. And a little bit of wiping off the old paste. All my cards are getting a paste upgrade today. I ran out of my typical actually, funny story, the Noctua 40 millimeters will not fit. They are about twice as thick as the stock fans that are on these. But because I have run out of MX2, all my cards today are getting KPX. Nice blue. Paste. And like I said, we'll also be doing practical demonstration later, so I have to paste swap all these cards anyway. Here we go. And we'll start with just a couple. Funny enough, when it comes to older computer stuff, about the oldest I go is about GTX 200 series, so anywhere around 2009 is about where I make my cutoff on oldest cards I'll buy. There are some exceptions though. So, now that I've covered the basic hardware specs of this one, can move on to the next card. So the next card we'll be looking at is the Galax GTX 460 WHDI or WHDI edition. It is a wireless GTX 460. So we'll set this off to the side. And this is our next victim. So this card actually pairs to this, and you plug your monitor into this box, and then from up to 100 meters away or no, to 33 meters away or 100 feet, this GTX 460 can wirelessly communicate with this box, excuse me, and with about 1 millisecond latency transfer a 1080p 60 FPS signal. And this card is not just a graphics card. So if you notice, compared to a normal GTX 460, this thing is way longer than a normal one, and the core is really far back from the edge, and we'll get into that. So this card is relatively simple. It's just 6 screws, much like the 7970 SOC. It makes me sad that I'm about to repaste this one. This one only got ran twice on this paste since it was last repasted about 3 months ago. But I wasn't the one who repasted it. If you would like to see a another teardown video just focused on this card, my friend Commander Soyo on YouTube, I typically send some of my rare cards to, and he will do breakdown videos, and we'll discuss these cards in depth as well. I buy things through Europe and ship them through him, and he gets to make YouTube content. So here was that. Wow, that contact paste was not very good, and I know he just repasted this, but onward we go. So this is the GTX 460 WHDI. It uses a 4+1 phase with the Chill 8314 controller right here, and it has Samsung EDI. And underneath this electromagnetic shielding is a Amamom 2120 transmitter chip with a power amplifier module, an ARM CPU, and a decoder chip all in one. And it can transfer up to 3 gigabit per second over these 5 antennas. It uses a standard GF104 die. It has a normal amount of 1 gig of VRAM, but unlike a normal GTX 460, it has no SLI fingers. This card cannot be SLI'd because of the all the extra lanes went towards this, and so it doesn't have the capability of SLI anymore. And the VRM on this thing is actually slightly better than reference. The reference GTX 460s typically came with a 3-phase. Not saying that this is a particularly powerful VRM, but it is better than stock, which is a lot better than what a lot of cards can claim. So, just gonna carve all the paste. Might be time for me to grab another paste rag. And it does come with a rather substantial VRM block on it, which I'm actually going to reattach early, because this thing is actually a pain to put on. Oh shoot. Ah, there we are. Once you get the first one on, it's a lot easier. So what's interesting is, even though you have all this space on it, and you're like, oh, you could put a really massive cooler, the cooler on this thing is actually very tame. It's just a one fan, a reference slot design. It's very pedestrian for what it is. Unfortunately, there was a placard that typically comes in this slot that would say KFA2 or Galax. The story behind that is Galax stood for Galaxy, and Samsung or it was Microsoft or Samsung, I forget which one, actually ended up suing Galax because they had the copyright for Galaxy for their phones. I believe it was, I forget who, but yes, so they sued in the European Union and won. And so Galax had to change their name or pay royalties. And so in Europe, Galax is known as KFA2, where everywhere else they're known as Galax. Fun little history for you. It's the same reason as in the UK, if I remember correctly, McDonald's decided it'd be fun to sue a small burger joint that was named Max and claimed it was trademarked, but because they were there before McDonald's was, they lost. And so now Burger King over there has burgers called Not a Mac because they lost that name. But in this case, Galax lost, and so they did lose the name to their company. I would take this card farther apart if it wasn't for the fact I'm scared of breaking it. because I have no idea how that ARM CPU works. It's not very common you have a graphics card with a whole CPU inside of it. Although it would have been funny if this card was the prefix to an NVIDIA ARM merger. Unfortunately, that did not pan out. So, yeah, we had the GTX 460 WHDI, and the WHDI actually stands for Wireless High Definition Interface, and this uses the same technology as what the old like iPhone 4 had for screen sharing, where you were able to take your screen and on your iPhone and share it by Wi-Fi. This does the same thing. It actually creates a Wi-Fi network over the ARM on here, and this box connects to it, and that's how it's able to transfer data so quickly with such low latency. And the last up on our list is the GTX 480 Lightning. Now, the Lightnings, or the GTX 480 Lightnings, aren't exactly rare, but they're not common either. These were made for less than 3 months. The reason being is because MSI took a very long time to develop the motherboard and the layout of this card, and then as soon as they launched this card, the 500 series came out. So, for reference, the GTX 480 came out in March 26th of 2010. It took them 7 months to release this on September 20th of 2010. And the GTX 500 series came out 3 months later in November 9th of 2010. So there was less than 3 months where this card was effectively being made and sold. So there just isn't that many because there wasn't a lot of time to make these before they were obsolete. This one uses Pro Idolizers as well. It is a much older design though. So the 7970 SOC came out in 2012, whereas this came out in 2010. And the Pro Idolizers were a relatively small blip in technology, so worked really good, it just didn't last. And I'm breaking the paste on. Oh no, this one has KPX also. So, this one has the GF100. I did not delid this one. You can delid these and do direct die cooling, which improves performance a fair bit, but due to the uncommonness of this card, I won't do that. Let's see, get all that paste off. So we got the full GF100. So there are 3 gig variants of the GTX 470 or 480, and there are 1.5 gigs. The Lightnings only came in the 1.5 gigabit flavor, but there are 3 gig variants from, if I remember correctly, Asus made some, but these cards always came with this it's like it's not a back plate, it's more like a front plate, and it helps heatsink all the memory and the VRM as well. And there's an LN2 bracket that used to come with these that is just the VRM portion of the card, and what it allows you to do is when you go to mount a liquid nitrogen pot, those pots will interfere with this portion of it because they sit so flush against it. So what you do is you have just the VRM heatsink on it, and let your memory modules be cooled by the radiant cold of the liquid nitrogen pot, and just go off. Your BIOS switch is here, and this uses, let me go ahead and take the back plate off. This one technically has more components worth for phases as the 7970 SOC. However, it actually has 2 less phases. So the 7970 SOC is a true 8-phase design. The 480 Lightning has 12 phases worth of components, but it's actually just a doubled 6-phase. There we go. And once I get this backplate off, it'll be easier to explain how you can tell if a card has a doubled phase design, especially on older cards. On newer cards, you can look for doublers, where you'll have 2 power stages in a smaller square package by them. That's typically an IR 3995, and that is typically how you can take a controller that can say only control 4 phases and make it control 8 phases worth of components. However, this one has a 6-phase controller, and this part is always sketchy because it's typically really stuck on there. There we go. Oh no, tore the thermal pads. Oh well. Just stick them all back on there. But, so we have 12 phases worth of direct FETs. And you can tell a direct FET because, unlike a normal power stage that we have on modern cards, these direct FETs have exposed metal tops, and these are live. So unlike a modern one that has a plastic coating on top, these forego that, and these can carry a ton of amperage. Their weakness, though, is they get very hot, and these are capable of doing, if I remember correctly, 60 amps each. However, that is only at the nominal temperature of like 35 degrees Celsius. If these hit 75 degrees Celsius, the amount of amperage each one can do is more like 15 to 20 amps. So if you have 12 phases worth at 20 amps, you still have 240 amps roughly, which is fine for a graphics card if it's under, you get to a point where you have the amperage of these, when it heats up, it produces more heat, which causes the amperage to go down, which causes it to heat up even more, and you'll end up getting in a VRM thermal runaway situation. So you have to really control the temperature of the VRM on these for it to be able to carry the capacitance to properly feed the card. Which is why the backplate of these is really important. The another unique part is this is one of the only 480 Lightnings that has 3 power connectors. It has 2 8-pins and a 6-pin. The 2 8-pins are to solely feed the VRM of the V-core. This last 6-pin is to feed these 3 phases right here, and that's it. They have the memory VRM, and all the supplemental power is fed from this 6-phase. Now, a fun note is these have voltage monitoring points. So you can take a small probe, put it in there, and you can monitor the PLL voltage, which is like your display driver voltage. If you get cold enough and your PLL isn't increased, your display output can drop out under load. So you can monitor your PLL. You can check your memory voltage, which using MSI Afterburner, you can mod all the rails on this card. And then you have voltage for GPU. You have your BIOS switch between normal and LN2 mode. On LN2 mode, you can push up to 1.8, if I remember correctly, volts. It's a lot. And the way you can tell that this is a doubled 6-phase is you'll have your inductors on the back with your inductor legs, and you'll see this little T shape of solder points between every other one. And these are physical bridge connections that are linking these two inductors to the core. So, and here are your doublers. So you have 1, 2, 3, 4, 5, 6 of them. So what this is doing is this is taking the PWM signal from the controller here, and it is sending it to each of these. And then from here, it is sending PWM signal here and then here. And these are smart doublers. So they can be run in one of two ways. They can be run as a dumb one where it cuts the PWM signal in half, and then this one will do one and that will do another, effectively running them at half speed, half the switching frequency, so that they don't overheat, and you get the output of the current capability of one, but they'll run a lot cooler. Or they can be smart doubled, in which it'll feed both of them the same PWM, and so you get the power of two, but they'll heat up faster. So, and they also do smart monitoring, such as temperature and stuff like that. So even though it's a GTX 480, you actually have VRM monitoring, hotspot monitoring, and all that. And then this line of LEDs back here tells you which phases are currently being active. So I'll reassemble the card real quick, and then I'll just grab the fish off my test bench, and we can start with the final portion where I'll start running a test with them. For the test today, I'll be running a mix between Superposition from Unigine, and I'll also run Unigine Tropics. Alright. It's a real big sandwich design they got going on here. So you gotta like line everything up perfectly. But as stated before, it is a needed design for the thermals of both the VRM and the memory doesn't really run hot. Like GDDR5 has never really been a hot running design, but it doesn't help, or it doesn't hurt. on some cases it actually can hurt if it gets too cold. All right. Just tighten up these, and I'll attach the core. Call it a day. If I do another stream, I'll be doing a stream with the... I think I'll do the GTX... I don't know. I got a couple GTX 580 SOCs, 1070 Katana, which is really modern, but I don't know. I would have to see if it would qualify being it's uncommon. I have some engineering sample cards. If I'm able to get a XP bench going, I have some really old cards like a Matrox ISA Storm that I can try out. But as said before, going that old is not my forte. The 5770. I actually have been really wanting to buy one of those 5770 killers. That's another one of those really uncommon and rare cards that you just don't get to see often. Like I said, I've been collecting graphics cards for several years now, and I think I just hit 80 in my collection. But these are just some easy ones that are able to be set up and run. And let's see. Nice and warm. This has been running the whole time, so this is a passively cooled GT610 fish, also made by Galax. So I've been thinking of painting my fish red. I really like just the colors you get with these. This is what Galax thinks an overclocking focused GT610 that is passively cooled would look like. These were actually designed with overclockers in mind, so you don't always, like, if you're doing CPU overclocking or memory overclocking, you don't always want the biggest and greatest graphics card, for the simple fact that these take resources and they're not easy to run. That and overclockers are just lazy from experience. You know, if I wanted to set up a bench, I don't want to have to plug in 3, VGA power cables to get one graphics card working. It's much easier to just plug this, man, I got hiccups. Plug this into the PCIe slot and call it a day. But then Galax was like, well, we got a GT 610, and we can pair it with 2 gigs of RAM, and then on top of that, we can, well, that just came off. Yeah, we can pair it with 2 gigs of VRAM, and then put voltage monitoring points and overclocking features on a card that you can't really overclock. Which is part of the reason why I love Galax. They just do weird things with graphics cards that nobody asked for, but boy is it fun. There's an OCZ version of this fish for the memory, and these are not easy to find. They were sold almost exclusively in the Chinese market, and you have to import these if you really want one. You can find them for about $75 though. But there's an OCZ version that is legitimately rare, and only like 30 of them were made and given away to competition. But these are uncommon enough to find here in the West. You have voltage monitoring points. You get, I think it's a 2+1 phase. It's a very simple VRM. And they actually have a actively cooled version of this card, which is why there's a fan header. And it's ugly. Like, not gonna lie, it's ugly. But I'm not the one to judge. There is a 710 version of this card as well, and yeah, it's fine. The 710 version actually has an HDMI port natively, unlike the 610 that only has DVI and VGA. So let's see. Just way too much paste on purpose. Smush and smear. That is a very rough cooler. But let's see. Line this up. And we'll go in the same order as before. Actually, we'll start with the NVIDIA cards because I have an NVIDIA driver installed. So I think the easiest one to demonstrate first would be, we'll just go in reverse order. We'll start with the fish. And this is where things get a little tricky because now I need to reposition my camera. And I get to flip the display. And let's see, transform. flip horizontal, and then flip vertical. Scene. There we go. That actually works out really well. And because I've been lazy, I did not bother changing out what my test bench was. So this is my test bench. It is a Rampage 4 Extreme running a 3930K at 4.8 gigahertz at the moment with 16 gigs of DDR3. Alright. And this is actually not even, well, this is not actually even the proper test bench screen. This is a secondary of my, this is just a capture of that. So, here we go. We'll start off with a Tech Power GPU-Z, and I'm using the wrong mouse already. Fun. So we have the GeForce GT610. It has 48 shaders, 8 ROPs, and this one is on a GF119, which is Fermi, despite being a Kepler architecture, like in the name. This is common on low-end cards. It uses DDR3 with 2 gigs. Since this one runs DX11, we shall be running, let's see, I believe Superposition is DX11. Yes. And here we are. Now this card is not overclocked, it is completely stock. Oh, and we're about to hit 1 hour. I'm doing pretty good. Just run through these couple of cards, do some benchmarks. Should be out of here by an hour and a half. Not bad for covering 4 cards. If things crash, I am just going to leave them be. This card was never designed for 3D loads. It was designed only for 2D loads, and as such, I came prepared with a small fan. Because passively cooled cards doing 3D loads is not a cool thing. This card it'll run 2D loads all day just fine. It will not do 3D loads. Because even if you were to make a passively cooled card, the design of the fish is really bad. It is big, chunky fins that are meant to more absorb heat rather than dissipate it. This card very quickly will thermal throttle at 100 degrees without any airflow. And I'll let it run about 5 or 6 scenes on each one so that you have a baseline understanding of how it would perform against each other. As you can see, this one's running a crisp 2 FPS. This test takes about 8 minutes though, so I'm not going to be running the full gamut. Alright, and we shall call it there. And we'll just run 1080p medium preset on all of these cards. So, that was the fish. Now, on to the GTX 460 WHDI. Now this card, unlike the previous one, I will not be plugging the HDMI cable into that, but rather this box. And this will be to show that this card is working wirelessly. Just for reference, I typically rip out the PCIe retentions on my test benches. It's too much hassle. And this one only needs 2 6-pins. And for the best performance, you're supposed to make this into a like Cthulhu W shape, because of how radio or the frequency waves bounce off of it. I don't know. I'm not a guy who deals with Wi-Fi waves, but after a couple of seconds this box will connect and you can see it on the front. This light will turn green. It's hard to tell. Alright, and it's still posting. Alright, you should start getting the postcode. Network is connected. We have video output. And there we go. We have wireless display. Because it is a new graphics card, it will take a second for the drivers to kick in. This can be remedied by just forcing a 3D load on the card, which will cause the drivers to pick up. And there we are. So this one is less than ideal on how it looks on the capture card, but let me see here. Video. Alright, and let us restart. Let the driver fully initialize. Ooh. That is an artifact of the capture card, not the graphics card. There we go. Ah, it's running 1080i. That explains a lot. This capture card does not like interlaced video at all. Change resolution. Now, I forget. I think it only does 1080p. I think it does 720p. Yes. There we go. It'll be a lot clearer with 720p display compared to 1080i. This is a limitation, if I remember correctly, of the this was 2012 graphics cards trying to wirelessly show 1080p. So let me see here. Control panel, customize, create custom resolutions. So this should be, I think we can force 1920. Oops. No. I think we can force 1920 by 1080p, and then I'll run the graphics card test again. 1080. 60 progressive test. There we are. Yeah, so I do remember correctly. Yeah, this one can do I don't think it's stuck. Apply. There we are. And it's hard to see. Yeah, it should be stick. This is not my normal background, obviously. It's the GPU June 2, so I'm not used to seeing it as such. But we can run superposition. I'm running all these stock, not overclocked. That way you can see like for like stock comparison runs. So this one will be VRAM limited, whereas the GTX Fish had 2 gigs of VRAM. The GTX 460 only comes with 1. This graphics test would like to see at least 1.3 gigs of VRAM. So our 0.1 and 1% lows should suffer, but overall it should be better than 2 FPS. I don't know why this takes a while on my test bench to load. But common use cases of the WHDI was in like schools, churches, places like that where you, or like businesses where you had a TV that was mounted away, but you didn't want like a long cable running to that, or you know, maybe a projector where you had a projector way out of the way and you wouldn't be feasible to run a HDMI cable, you know, 100 feet. You could, in theory, just set up this graphics card, set up the box, buy it, and wirelessly stream it all. It had some limitations, FPS and the resolution, but it worked quite well for 2012 implementation. And we're seeing about a 14 to 15 FPS. So let's see. Gonna cancel it here. And we can move on to the GTX 480. And we'll slowly work our way up to the most powerful graphics card. One thing I will give props to Galax to is they really enjoy making their they really enjoy making their heat sinks on the outsides of their graphics cards part of the heatsink, or like the shroud for their heatsink, part of it, and the implication of that is, well, you gotta remove the graphics card and it's hot. And they put warnings on it too, like caution, hot, but still. Well, most of them typically say caution, hot. This is one of the ones that we actually need an adapter for because it does not come with HDMI. And this one requires all 3 VGA power cables. And here we go. I totally forgot to plug in the fan. Or did I? Nope, I did plug in the fan. And yeah. If I remember correctly, this card works. Ah, there it goes. Maybe the connection was just loose. This is a feature I wish they would bring back. Replaceable BIOS chips for motherboards. I'm kind of lucky the GTX, because the GT610 Fish is, you did not fail overclocking. Because the GT610 Fish is actually based on a Fermi design, all 3 of these cards use the same drivers. So that's why I chose these 3 for the first demonstration. And I've already downloaded and installed the AMD drivers needed for the 7970 to keep driver times at a minimum. This is another case of this card was so rare it kind of didn't get to take all the leaderboards and be known as the most powerful. Huh. Well, that's interesting. Nope, not overheating on the... to run. Just give it a second to reboot. I'm running a super light version of Windows 10. So it has some quirks with it. But this goes back to, I don't do content creation, I do overclocking. But compared to like the GTX 480 from like EVGA with the classified, or the Asus's GTX 480, they were typically better than these because they actually spent more time on the market. More people were able to get their hands on them, push them harder. So they were known for that, but the 480 Lightning just wasn't able to be pushed in the same manner. Put a load on that, and just like that, drivers kick in. Hey. So, now to look at the GPZ on this one. We had the GF100 with 1.5 gigs of GDDR5. This one has 48 ROPS, 480 cores. I always liked how it lined up, 480 shaders to the GTX 480. And we shall run Superposition. Now, because this is actually a Lightning, here is one of the notes of MSI Afterburner. This one is the which version of Afterburner is this? I believe this is the hardware bot edition. It might not be. But if you click here, you get memory voltage, auxiliary voltage, and core voltage, which on this one goes to 1.4 stock, and then on LN2 allows you to go to 1.8 volts. You will blow up the graphics card before you actually are limited by the voltage. Desktop audio. Well, that explains why there's no music. And we went from 15 to 22 FPS. And as stated before, these are all just stock versus stock. These things can actually go way farther. You can do about a 33% overclock on a GTX 480 where you're trying to push a 1 gigahertz core on these, and you can actually come reasonably close. Yeah, you can come reasonably close with that. The catch to that is, there we go, that these things draw a lot of power. So We've slowly gone up in clocks, and now to the ultimate one. Just that short test, this thing is already very hot. It has a exposed heat pipe on top. And I'm just using an analog because I'm being a little lazy at the moment. And this is one of the few times that you actually need one of these to hold the card, because this card is very, very heavy, and it does not like to sit properly. And there we go. When these fans are very old, like I said, these fans are brand new. When these fans are very old, this card gets very, very loud. It is easily will gain 4 to 5 times how much louder it is. And eventually, because these are 11,000 RPM fans, they will the fans, when they become brittle, will just start shattering when you turn them on because of how fast the blades move. And I think the driver already kicked in. Sweet. Oop. Yep, MSI Radeon. So let's look at that GPU Z. And as you can see here, we got 2048 shaders, 32 ROPS, 3 gigs of memory. This is also GDDR5. Why is it? Oh, it's already overclocked. Fun. So it's running at 1300 megahertz core. I do not remember. Okay. So, yeah, this one is already running overclocked out of the box. And we can run Unigine again to see its performance. This one should be... This one came the generation, or 2 generations after the GTX 480. If I remember correctly, this one will be around 50 FPS or so. This was competing with the GTX 680, and this was when NVIDIA was, or when AMD was last competitive with NVIDIA in the graphics card space for quite some time. And so this card would trade blows with the 680 depending on how the game was made. If the game favored OpenGL or was optimized for AMD or Radeon, this card would win. If it was optimized for NVIDIA or highly optimized on DirectX, the card would typically lose out. I think this card actually crashed. Yeah, I think it crashed. I should have disabled the overclock and ran it stock like I said I would. But last run, and we're at an hour and 25 minutes, so we're about to hit my goal of an hour and a half. Spot on. Reset. Alright, So 1080 core, 1375 memory as it should be. And auto fans. And I'm not doing any of my optimizations on these. And once it loads, get this final test out of the way, and that will conclude the stream. Whenever it decides to load. That's one of the downsides of using Unigine, is it does have a long loading time compared to many benchmarks. But there we go, 50 FPS roughly. Staying at a toasty 42 degrees Celsius. And the fans are barely even audible. And the way it works is it actually sucks up air through here and through the side and just pulls air up through the top. It's quite a unique way of cooling the card compared to many that just shove air at the front. And here we go. And so that concludes. Let me transform. Video capture. Transform. Oh Lord. Let me fix this. Configure video. Camera control, zoom in, apply. Alright, so well, this is awkward. There we go. So this was my presentation of the GTX 610 Fish, the GTX 460 Witty, the GTX 480 Lightning, and the 7970 SOC. And appreciate any feedback. Like I said, I apologize for not being the most organized. I don't typically stream. I use my capture card for extreme overclocking where I'm using liquid nitrogen. But I had the equipment and I decided why not. Anyway, thank you and enjoy, or thank you for watching.